Put it on the water thing. I just thought that it was like rebound. No, it's overflowing. No, oh, I still feel like not overflowing.
Okay, let's get started. Please, we've got lots to do. Let's talk about this question too, just so we're clear on how it was marked. In general, the quizzes were pretty good. There were some errors that were made. We take a look at this, the first one. Okay. I would give you 1 mark if you just turned everybody into sine and cosine. There are still some of you that fail to give me the angle. I gotta admit, it's making me mad. Right? If you write just sin, like if you just write this with no angle, that's bad, right? That you go to hell for that. That's a sin. We do sine x, so make sure you include your angles. It's just such a shame when you're going to write the provincial and then you're not going to do it on the provincial, and they'll take it off every single time. So make sure that you have an angle stated. So there's the initial, that's worth 1 mark. Then if you apply any appropriate algebra, and it can even be algebra that takes you down the wrong path, but as long as you apply some appropriate algebra, you're good. If you do this, you're building a common denominator. We do this all the time. And then you show that you've created that common denominator. And we got common denominators in the top and in the bottom. And then once you do this, you're now at 2 marks. Now the question mark is, what are you going to do next? Normally we're going to try and multiply by others. Did I make a mistake? You're right. That makes a big difference. Thank you. So this should be sine x. Thanks, Jane. And then here, if you catch it, and it's funny because this is one of the questions in the green booklet. So if you did every question in the green booklet, hopefully you saw or remember doing this one. And if you didn't do it, then too bad. Then you factor out the sine x and you're left with cosine x plus 1. And then you're going to multiply by the reciprocal. And you should see that this binomial, and be careful, make sure when you're canceling a binomial, it can only cancel with another binomial. And then when you put it back together again, can you see your numerator will be sine squared x over your denominator cosine x? That's about the standard level of an identity that you'll face on my test, and also about the same level that you'll face on the provincial. Good. On the back side, lots of you guys did great things here. I'm not going to spend too much time on it. I think it looks like this. It's going to be y equals. My memory's not great today. I think you find out that the a value is 8. Most of you built me a cosine function. The period is in fact 10. So if the period is 10, this better be pi by 5. Some people write it now as 2 pi over 10. I gotta admit, I'm not completely against that, right? 2 pi over 10, like bearing in mind that the b value is always just 2 pi divided by your period. So if you wrote it as 2 pi over 10, you might lose a half mark for not being fully simplified, but it's not wrong. And then make sure you're careful with your brackets. You know me, I like my hard brackets. And this is going to be x minus 2 because we're starting at the maximum. And then the average works out to be 7. I did have some people get a bit creative. They gave me the sine version. So here's the sine version. It's 8 sine, so it doesn't change your amplitude. It doesn't change your period. However, they found the logical starting place was actually at minus 1/2. So then they wrote this as plus 1/2. I thought that was pretty cool, and that's true. And we talked about, and this one, of course, starts on the average, right? Remember, sine starts on the average, cosine starts at the maximum. Again, I don't ever worry about sine, but if you want to give me sine, that's fine. I think cosine's easier. And then this is an interesting debate. We had it this morning. I know the function is supposed to be 8 cosine pi by 5 and then x minus 2 plus 7. And I'm simply initially asking, when does it equal 2? Correct? When does it equal 2? If you follow through with the math here, I think for most of you, and be careful too on the exam and on my test, make sure you say let theta equal the shenanigans. Can we call them shenanigans? Okay, so pi by 5, x minus 2. And then you can rewrite it 8 cosine. And some of you guys, like, you may not like this, but you guys are a little bit lazy sometimes. And I get that, but it's going to hurt you if you're not careful. And you want to earn all the marks that you deserve. You can end up generating for me like cosine theta itself is equal to minus 5 over 8. And as you move forward, you're going to tell me that the reference angle is the cosine inverse. And you know by now you have to use the positive version. And you know you're not supposed to round it yet. And you guys are doing a good job of giving me my dots because I like that. Okay. Then you're supposed to explore the fact, when is cosine actually negative? Cosine is negative in quadrant 2. It's also negative in quadrant 3. We've rehearsed this a number of times. You're going to do everything in quadrant 2 first before you tackle what's in quadrant 3. It's just easier on your calculator. You know the angle that lives in quadrant 2 is pi minus your reference angle. I don't need to see the numbers here. You should just have them in your calculator. And this works out to be 2.245 ... Then we talked about the translation of the shenanigans. We know that it's pi by 5 multiplied by x minus 2 is equal to this number. You don't have to show me what you did here to find the value for x. Just make sure you know that you multiplied by the reciprocal, 5 over pi, and you added 2. And when you finish, this should work out to be 5.575, and you can round now. So that's the moment, or the first moment, our function equals 2. Then you're going to reload your calculator. You're going to take pi and add your reference angle. I don't need to see those pieces, but I do need to see the new reference angle, which is 4.037 ... Then I'm going to remind you that theta represents the following. So show me that. And then use the number in your calculator, multiply it by 5, divide it by pi, and then add 2. And you discover the other value for x was 8.425. And then I wasn't very clear in the question. So if you got to here, you got the 4 marks. Because some people were debating, like I asked for the interval. So some people said the answer is, well, the interval would be, arguably the interval would be soft bracket 5.575, comma 8.425, because it says just less than, it doesn't say less than and equal to. I didn't distinguish that. I was fine with it. What I really wanted people to do, honestly, is I wanted to know how long were we below 2. I was looking for the time interval, and the time interval, if you did the subtraction, worked out to be about 2.85. I'll try to be more clear when I ask the question in the future, so that way I wasn't too concerned. If you got me these 2 moments, then I was pretty happy with your response. If you got a question here and you saw me write this, okay. When I write okay, and some of you have that in front of you, it means you've done something that I don't necessarily like, but I'm not sure Well, the best example here would be some people gave me the wrong function, but all the math that they did with the wrong function was correct. So for example, they gave me the wrong function here, and then they used the wrong function, but it's the same wrong function. And I don't need to punish you over and over again if you're using the wrong function. Now, I got to admit, there's a part of this for me too, where if you really want to be difficult on the provincial exam, you just give me the wrong linear function and then tell me when that linear function is equal to 2, and arguably I still have to mark it right. Okay? So it's one of those silly sort of loopholes if you don't like a question, but you guys have enough to worry about than worrying about that. Okay. Any questions about the quiz? Test right now is tentative is the good word for it, is for Friday. We are getting to the end of this chapter pretty quickly. I do want to take a look at Friday's homework. I want you to take a look at your homework from Friday. There's some interesting questions in there. I asked you to consider 15, 19, and 20. So speak now. Again, the quality of your education is a function of the questions you ask me. Jay, which one, A or B? Okay. So Jay, it tells us that the cosine of theta is equal to 3/5. And I know when someone asked me this question, I asked, like, what quadrant are we in? And I guess the first answer would be, Jay, what quadrants could we be in? 1 and 4. And then we look at the instructions here, and it's not very helpful because doesn't the instructions in the question suggest we are pretty much anywhere within 1 rotation? So that means we actually have 2 possibilities for sine. All right. Can we draw the right triangle that honors this cosine ratio? So I want you to always remember that when you say cosine theta, it's just a fraction. The adjacent side is 3. And the hypotenuse is 5. So then, Jay, how long is the opposite side? 4. So that means, and based on our information, isn't sine theta equal to plus or minus 4/5, depending on what quadrant we're in? All right. We know we're supposed to be describing sine of theta plus pi by 6, correct? We know that the sum identity for sine looks like this. Isn't this the the sine of the first angle multiplied by the cosine of the second angle? Sine is the good one, so it's going to be plus the sine of the first angle multiplied by the cosine of, I said it wrong, but I did it right. Okay. Does it look like ABBA? Okay, that's good. And if we assume that we're in the first quadrant, then the sine value would be positive, and we just found it, it's 4/5. Cosine of pi by 6, J, is an angle we recognize, and it ends up being positive √3/2. Plus, the sine of pi by 6 is also a moment that we recognize on the unit circle, and the y value there happens to be 1/2. And then the question told us this was 3/5. And it doesn't take much to clean this up. It's just 4 square roots of 3 plus 3 all over the shared denominator known as 10. Congratulations, Ridley. If we happen to be in quadrant 4, because it doesn't tell us which quadrant we're in, because remember in the instructions we weren't sure because it said the angle could be any angle between 0 and 2 pi. If we happen to be in quadrant 4, the only difference in quadrant 4 is the sine value would be negative. Everything else would be the same. So then the final answer, the other option, maybe that's a better way of putting it. The other option would look like this. Does that help, Jay?
Yeah.
Okay. I like that question type. Like it forces you to do two things, right? It forces you to find the value based on the right triangle, and it forces you to remind yourself about the unit circle. Any other questions? This is your education. No one's more invested in this than you. Do you have any other questions? So if I gave you a quiz on this tomorrow, you'd be good?
Yeah.
Carmela. 20 letter C? Absolutely. Oh, everybody, this is like the happiest question. Everybody's in quadrant 1. Okay. Thank you for asking it. They tell us that the sine of A is equal to 4/5. So can't we automatically tell you that the cosine of A is 3/5? If you draw out the triangles, you'll see that I'm right. Are we okay with that, Jet? If I tell you the sine is 4/5, cosine has to be 3/5 using Pythagoras? Okay, well, now, because you paused, I got to show you that's your punishment. So when I say this, Jet, when I say to you the sine of A is equal to 4/5, you know we're talking about right triangle trigonometry. I'm going to put angle A right there. Sine means opposite over hypotenuse. Therefore, the other side can only be 3. And if that's the case now, you could tell me the triangle where A is trapped inside, right? The triangle where A is trapped inside, the cosine for the same triangle from A's perspective would be 3/5. It's going to be 5, 12, 13. I'm not ready yet for that. I need the pieces of the puzzle first. So there's cosine A and sine A. So we got everything. We could have you like surgically attached. Like you guys could be the opposite of Siamese twins or become Siamese twins. Okay. All right, next. The second part of the question says cosine of B, and it describes cosine of B as 12 over 13. We understand, again, we're talking about right triangle trigonometry. B is the angle stuck in the corner. And in this case here, the adjacent is 12, the hypotenuse is 13. And then if you use Pythagoras, you'll discover the other side is 5. And as soon as you know that, you now know that the sine of B is 5 over 13. Better? Because we got two angles, right? We got everything we know about angle B and everything that we know about angle A. When in this I'm not sure, because in this question, if you listened, they asked us to find the value. You ready? For the, wait for it. I probably did more work than I needed. We're looking for the cosine of 2A. We know there's 3 different ways for us to describe it. And now I wish I didn't do as much work as I did. Because the truth is, weren't we given this right at the beginning? And believe it or not, if we were smart, we know that the cosine of double angle A, 2A, is equal to 1 minus 2 sine squared A, which tells me I only needed that one piece of the puzzle that I highlighted in blue. I just got carried away showing off how to find the other pieces. Now, the truth is, if you do question number 20, if you do A, B, C, and D, you will need to know all the other pieces. But the question that was asked by Carmela was, how do we do cosine of 2A? And I'm glad I'm doing this. It's going to be equal to 1 minus 2. Do you remember the fraction for sine A? Not sine squared, but sine A. I'll scroll back in time. 4/5. So it's the fraction. This represents sine A, which you are then going to square. From here, yeah. So when you solve this, it's going to be 1 minus 2. When you square this, it's 16 over 25. And then let's not make a mistake now. This is going to be equal to, is it okay, Jet, if I rewrite the number 1 as 25 over 25? Minus 2 times 16 is 32 over 25. And when the fractions have the same denominator, I can just subtract the top. The final answer is minus 7 over 25. So just so that we're clear, it's on your cheat sheet, but you need to remember that the cosine of 2A is equal to, I'm going to give it to you one more time. Remember, cosine double angle is always cos, cos, sine, sine. So the first version is cos squared A minus sine squared A. That's the first version. Then we do Pythagoras identities to get the other two. The next one is 2 cos squared A minus 1, because we replaced sine squared A with the Pythagoras identity. And then the last one will be 1 minus 2 sine squared A. They're given to you on the formula sheet, but you need to understand when to use them. Ridley. You can have that formula sheet if you, I'll try again. Don't write on it. If you don't write on the formula sheet, you can use it in any test and any quiz I give you moving forward. You can write your name on it. You can write Mr. Harley rules on it. I love math. Things like that.
So, what's the difference between a double angle and
What's huge, right? You're going to see it more so today when we start solving some equations that have double angles and single angles in it. Hey, you're welcome. No other questions from the homework? Speak now. We good, Victoria? We good? Okay. All right, we're moving on. It's a great title. First question. So we can solve, believe it or not, every single question. We're going to do 4 of them. And at no point do you require a calculator to solve them. Okay. So the first one looks like this. Can you solve, and it's sine 2x, so it's the double angle for sine, so sine 2x. And then we're going to subtract cosine single angle x. So notice it's cosine x. So there's two things that bother me already. I got sines and cosines, and they're equal to 0. So this is not an identity. You're not trying to make the left side equal to the right side. It's just simply an equation. All right. First thing that jumps out is I got a double angle and I got a single angle. My life is easier if they're all the same. And primarily, it's easier to switch double angles into singles. Is there a way for us, and isn't sine 2x a lovely double angle? What is the replacement for the double angle for sine? Victoria. Lovely. It's 2 sine x cosine x. And then when we make that substitution, can you see everything now is single angle? So if you check your list, Jet, you'll discover that there is a double angle replacement for sine 2x. It's known as 2 sine x cos x. It's on your list too.
Oh.
Might have been in a lesson or two. Once we get to here, I'm a little befuddled on what to do next. But believe it or not, if I see it, it actually turns into a very friendly equation. What could we do here with these two terms? Yeah, what do you say, Benjamin? Factor it. Can you see that cosine is common to both? And if you factor out cosine x, what's going to remain? So you're going to be left with 2 sine x minus 1 when you factor out the cosine x. And if you want to check to see that you factored it correctly, multiply it back together again. And if you multiply it back together again, does it return to what it was? Now, here's the great news. Now that it's factored, you can now change it into two different equations when does cosine x equals 0 and when does 2 sine x minus 1 equals 0. We've used this tactic many times. Well, where on the unit circle do you get x values of 0? Oh, I guess I should give you a domain then, right? Can I make the domain from 0 to 2 pi? So we're not going around forever. All right, where do you find x values of 0 when you're making a conventional rotation on the unit circle? No. Who's brave enough? Who's got the courage? Ridley. Ridley says pi by 2, when you reach the top, the x value is 0. But you know what, Ridley? When you reach the bottom, 3 pi by 2. So those are where your x values are 0. The second question, when you simplify this, we're asking you, where do you find, because it's sine, where do you find the y value of 1/2 when traveling around the unit circle? Positive 1/2. Where do you find it? So the first one that we encounter is pi by 6, I agree. Where's the other one? Perfect. 5 pi by 6. It's very tidy, no calculator required. Nice, comfortable domain for us to search within. There you go. Here comes number 2. In number 2, you got, zoom in nicely. You've got 2 cosine x, I like that, plus 1 minus sine squared x is equal to 3. And then the domain, let's make it the same, 0 to 2 pi. So, Benjamin, what's the problem? Perfect. We have cosine and we have sine. We don't want that. We want to try and avoid that if we can. What options do we have available then? Yeah, I love what you said. Like when we take a look at the 2 cosine x at the beginning, there's no options there. Like a single cosine x is kind of lame. But when you took a look here, and I love what you said, we know that 1 minus sine squared, and it's the square on the sine that knows that Pythagoras is around. So the truth is, you're going to leave the 2 cosine x alone. However, you know the Pythagoras identity, and the replacement here would be just cosine squared x is equal to 3. I will. I just wanted to deal with Benjamin suggested. Is it now all terms cosine? And then now we recognize that it's truly a quadratic equation. How do you solve any quadratic equation? You set it equal to 0. So like you said, it's now minus 3 equal to 0. And then after you set the quadratic equation equal to 0, you pray that and it does. You're going to create cosine x, and then another cosine x. This one factors nicely. You're going to just put plus 3 on one side and minus 1 on the other. That guarantees that you get plus 2 in the middle. And it guarantees you get minus 3 at the end. Now you can solve them individually. Can you tell me when we achieve minus 3 for cosine? And can you tell me when we achieve plus 1 for cosine? Well, will you ever get a value of plus 3 for cosine? No. Can we just like 2 options here? I think I like this option the best. Just nice and casual, no solution. I like that. Hey, Ridley, where do we find plus 1 in terms of the x coordinate on the unit circle? Perfect. But be careful of the domain. Make sure your answers are within domain. In terms of this question, your answers are. Again, no calculator was needed. All right, here comes the next question. We're going to start it off with sine squared x equals 1/2 tan x multiplied by cosine x. So that's interesting. We got like 3 different functions going. And then I'm going to make the domain kind of different, where it's 0 degrees less than or equal to x less than 360. Jay, do you have any advice for me? So if I can't see the problem, there is no problem. It's not bad advice. I like that. Hey, you could, because something actually happens that's really nice for us here. If you just turn tan into its sine over cos, doesn't that help us out kind of? So initially, if we're just trying to get rid of other functions, so sine squared x is equal to 1/2. If we rewrite this as sine x over cosine x multiplied by cosine x, I feel pretty good about that. And these cosines, they cancel. And then right away, lots of things are working out nicely for us. That's one thing too. You should know within about 2 steps, if not less than that, if you're traveling in the right direction. Okay. What type of equation is this? Is it linear? Is it quadratic? How do you solve a quadratic equation? Set it equal to 0 and pray that it factors. If it's okay by you, can I, just because of the nature of the equation, can I multiply both sides by 2? Could I not rewrite this as 2 sine squared x is now equal to just sine x? Well, math magic. Well, so do you see the equal sign? See the highlighted equal sign? Okay. And just ignore Ridley. Yeah. So the beauty of any equation is you can do whatever you want as long as you do it to everybody, right?
Yeah, and how does this cancel out the full?
Because if you take a look here, like we know that cosine x divided by cosine x, anything divided by itself creates. Okay. All right. Next line, we're supposed to set it equal to 0. So it's going to be 2 sine squared x minus sine x. That's supposed to be equal to 0. And just because there's 2 terms, that's not a bad thing. Usually that's a good thing. Just factor out sine. And then once you factor out sine, aren't you left with 2 sine x minus 1 equal to 0? And then just solve each piece. You know, this is asking the question, when does sine x equal 0? And when does sine x equal positive 1/2? All right, Kaylin. Where do you find y values of 0 on the unit circle? Okay, so I love that you paid attention to that. So 0 degrees, 180 degrees, and I was going to write down 360 degrees, but Kalen is too sharp for me. He already picked up that the domain says up to 360, but not including 360. So you got another option here too. You could write down the 360 and then you can put a line through it. So that's your way of telling me, like, I know it's a reasonable solution. It's just outside of the domain. Lovely, Kaylin. And then Kaylin, can you tell me where do we find y values of 1/2? Lovely. 30 degrees and 150 degrees. Great job. All right, here comes the last question. Number 4. So just so we're clear, when we finish this question, you guys will do some work, not just pack up and go home. I kind of let it go because it was Friday, but not today. You guys bailed out of here about 6 minutes early on Friday, and you guys did. Oh yeah, You guys would like this story. So many moons ago, when I think I was in like grade 9 at a different school that I don't want to announce, we used to have this art class that was on the other end of the building. There was no bell there. You couldn't hear the bell. And it was an old classic like analog clock where you could move the arms. You know what an analog clock looks like? And our art teacher was a little older, so we kind of took advantage of her.
Oh.
We changed the clock time. We made her time go a little faster. So, you come in and we moved the clock about 5 minutes, and then, we got out of there 5 minutes earlier than we should. And like any or grade 9 students, we got cocky. We figured if we move it by 5 minutes, we get out 5 minutes early. What happens if we move it another 5 minutes? So by the end of the term, we were getting out of there about 25 minutes early every day. Then I realized a few years later, I bet you she knew. And maybe she was the one moving the arm by the end of it, but who knows? Anyways, that being said, today class ends at 3:30. I know, heavens to Murgatroyd. Here's your question, and then I'll give you some class time to do some work. And the more work you do here, the less work you have to do at home. All right, cosine 2x. Cosine 2x. I'm actually very convinced she started moving the clock on her own. Cosine x. Right. So this is interesting. You've got a double angle on the left and a single angle on the right. And to make matters worse, when you find the solutions for x, I want every solution you could imagine. So I want a general solution. All right, good luck. You can do this, Jet. I believe in you. So this is one of the double angles for cosine, and it would make sense that why don't we just stay with everybody in terms of cosine, and then the entire equations in terms of cosine. That's right. I am replacing cosine 2x with 2 cos squared x minus 1. There's the replacement. Yeah. No, like all I've done is I have just replaced the double angle for cosine, and I've just replaced this. I haven't touched the cosines on the other side. Yeah. I kind of prefer radians now, but both are acceptable. Okay. As soon as you set this up, then you recognize this is a quadratic equation. So you must set it equal to 0. And then you pray that it factors. And I got some good news. It does. You're going to put -1 on the outside to get -2. You're going to put +1 on the inside to get +1. And then when you FOIL it out, it will simplify into minus cosine x in the middle. Now you can separate it into two separate equations. When does cosine x equal -1/2? And when does cosine x equal +1? All right. Mr. Brake, where do you find the x value of -1/2 on the unit circle? So 2π/3 is the solution that lives in the second quadrant. What about the other one? 4π/3 is correct. And then where do you find where x is equal to 1 on the unit circle? Where do you find +1 for x? Could be 0, could be 2π, could be anything like that. It's just the beginning over and over and over and over again. So if I'm going to organize my actual solution, I'm going to have to say therefore, because math people love saying therefore, x is equal to. So the first option is 2π/3 plus 2πn. The next option is 5π/, not 5, 4π/3 plus 2πn. And then the last option, can I not just describe the last option as just 2πn? And then because it's a general solution where n itself is an element of z. No, it's yeah, I'm okay with that. All right. This is your homework. It will seem like not a lot, and then when you get into it, it will seem like a lot. So I'm giving you good 15 minutes to get started, and I will help you if you have any questions. I'll also put it up on the screen so you don't have to dig it out. So it's 6.4, page 320, numbers 1, 2, and 3. Which seems awfully generous in terms of lack of questions. And then here, so here's number 1, number 2, number 3. One of the questions asks you to solve your solutions graphically. We will redact that nonsense. Okay. Okay. Please get to work. Thank you.
What would we do with this? Sine,
You
cosine.
just worry about the coefficients, you don't have to worry.
You don't, you can just ignore that after, just whenever x is equal to.
So, you're asking me a really good question. I'm supposed to ask me a really good question. Did you run into one that doesn't factor?
No, I just want to know in case.
Okay. Hold on, then.
Oh.
A good question.
I know it's just making me think. I'm supposed to make it. So, for example, here, just because it's simple. So if we pick something like, I don't know, let's make it like sine squared x, and let's say plus 2 sine x minus 5 is equal to 0. So we need to factor it first, correct? And you'd say, okay, well, the solutions would be x plus, or sorry, it'd be minus b plus or minus the square root of b squared minus 4ac all divided by 2. Okay. I'm gonna throw the numbers in, so it's minus 2. This will be 4. This is 4 times 1 times, this is why it's gonna work, minus 5 all over 2. So now it's a minus 2 plus or minus. This is 4. This is going to be plus 20. So it's a square root of 24. All over 2. We can clean this up a little bit, but because you're going to be, this would be a calculator question, right? You could describe your two options as minus 2 plus the square root of 24 all over 2. And then the other option is minus 2 minus the square root of 24 over 2. But these are, so I understand what you're asking me now. Okay. So this would mean then sine x is equal to this option, and sine x is also equal to this option.
Sine x, and then you have to do.
And then once you get that, then you'd have to do like the inverse to find the angle. Does that help? It also means like I don't even know if any one of these work because they might be too large. There's only one way to know. So the first one is you get a 2 plus the square root of 24. And then we're going to divide that by 2. See that right away is 1.44. So that's no solution. And the other one is minus 2 minus the square root of 24. Neither works. Like in terms of sign. Okay. Does that help a little bit?
Yeah.
Okay. You can have that.
Thank you.
It's a shame that both failed.
Yeah.
Yeah.